Hello students, right here again. Today you're going to start your book notes for for chapter 2, section 2.1, titled Units and Measurements. Other sections we'll be doing, 2.2 we'll look at scientific notation and dimensional analysis, section 2.3 uncertainty of data, section 2.4 representing data. So starting our section 2.1 using some measurements. Got 3 objectives here they give us. You're going to need to know about SI, base units for time, length, mass, and temperature. Going to need to explain how the prefix changes a unit. We'll also be looking at unit conversions there, switching around. Done your Hummer notes, as you should already. You've already looked at some of this. Compare the derived units for volume and density. Work with some problems on density again on Hummer. We've already done some of that. So through the notes, if it's in the Hummer notes and you have it, you don't necessarily need to write it. But again, just a reminder, anything that you do have in your notes you can use on the chapter quiz. Review vocab. The definition here for mass, a measurement that reflects the amount of matter an object contains. Lots of new vocab here you're going to need to make sure you have. Our main idea: chemists use an internationally recognized system to indicate their findings. This international system, called the System International de Unitas, SI, or International System, System International, and internationally agreed upon system of measurements, much like the metric system. Very similar, it's based off of the metric system. So, base unit, definitions you need. A defined unit in a system of measurement is based on an object or event in the physical world and is independent of all other units. So, in the SI we have 1, 2, 3, 4, 5, 6, 7 base units. You want to know these base units and the quantity and the base unit. So that's just time, seconds, length, meters. We'll use many of these a lot this year. We'll use a lot of time, meter, mass, temperature. Towards the end of the year we'll get to be working with the mole. Not so much in mole in this course, but in advanced chem we work a lot in mole. Electric current, advanced chems we deal with electrochemistry, a little bit there. Luminous intensity, not much at all. SI prefixes. You're going to want to know these SI prefixes. Know what their meanings are. We're going to be using them a lot. Should have already gotten a handout on this, and I think there was one in the Hummer notes too, so make sure you just keep track of that, but learn these units. You just need to know some of the more important ones we use in chemistry: kilo, centa, milli, micro, nano, pico. Lots of small ones because chemistry deal with little small things. Don't deal much with giga. Mega would rarely occur in chemistry. Deci, not too much. And here's some definitions for some of our base units: the second, a meter, and a kilogram. So, second, based on frequency given off by cesium-133 atom. Meter, distance light travels in that amount of time. And mass, kilogram, about 2.2 pounds. Yeah. Kilogram, there is a object over in France somewhere, and kept at standard temperature and pressure, and that is the kilogram. The meter used to be the same thing. They used to have a rod over there. That was the meter. Problem with this type of a thing is that anytime somebody wanted to check something against a meter, they had to go where that bar was. Now they have to go where the kilogram is. There are work being done now to come up with a similar definition like the meter for the kilogram, to where it doesn't have to have something to compare it to a physical object, but that we wouldn't have to go to France to be able to compare it. Temperature, got the Kelvin. That's one of the differences between what's normally called the metric system and the SI system. In the metric system, we would take degrees Celsius, and that's what we'll typically use in this class is degrees Celsius, but most of our formulas are going to be based on the Kelvin. 0 Kelvin, where there is no particle motion or kinetic energy, called absolute zero. We advanced chem and do unit on gas study, and we talk about how absolute zero was developed, and a couple other temperature scales. Celsius, I just mentioned a little bit ago, and Fahrenheit are a common one in the United States. Now, it says not all quantities can be measured with SI base units, which not necessarily true. It's just they cannot be measured very efficiently with SI base units. To make it easier and more efficient, we have derived units, which are a combination of base units. So derived units made up the base units, and you measured all the different base units. You should be able to come up with it from the base units, but much easier to come up with it in the derived units. Just here's a volume. Often measured in cubic meters. That's a pretty good size unit. More convenient is called the liter, which happens to be a decimeter cube. There's a place where we do see that deci. The other ones we frequently use is cubic centimeters, very common one, or milliliters. Those happen to be the same thing. So, different units of volume. Density, the amount of mass per unit volume. Most common unit we use, grams per centimeter cubed, or grams per milliliter. I just said those were milliliter and cubic centimeter, the same thing. And then we got the equation, mass divided by volume is density. Will be through Hummer's notes, and you should have looked at some calculations in class. We may have already done them, or we'll be doing them. We'll do some calculations on density. Derived unit. The liter is a derived unit. Kilogram is a base unit. Second is a base unit. So that's a base. That's a base. And the yard, and actually an English unit, so we don't even consider it in chemistry. Relationship between mass and volume is density. We just had that just a minute ago. So, that's a little bit on section 2.1. As always, if you read the section, add any other things in you wish. Good notes, always a good learning tool. Until next time, stripe.